Now this problem is again a straightforward question, easy problem. What is the amount of heat is required to transfer? So I want the amount of heat. So let us see. I am interested in what is the amount of heat that is transferred for gas to perform work done. So I have a nitrogen sample. Isobaric heating. So let us say what amount of heat is to be transferred to nitrogen in the isobaric heating process for the gas to perform a work done A. So work performed by the gas, that is dW, is given to you. This is equals to capital A. You have to find dQ. So what is the amount of heat there is? So let us say I have a system of nitrogen gas. What is the amount of heat that has to be transferred to the system so that this system can perform a work done A? So work done is given to you. That is work done is E. Now I want to find what is the amount of heat that has to be transferred. And it is also given the process is isobaric heating, that is pressure remains constant. So this means pressure remains constant, so PdV is simply work done will be dW will be PdV and PB2 minus B1. Are you getting? And I can also write for isobaric heating, that is PV is equals to nRT. If I differentiate this equation, PdV plus VdP is equals to nRdt, but isobaric heating dP is 0, so I will have PdV is also equals to nRdt. So now I can equate this process. So dW I can write in isobaric heating is nothing but nRdt. Are you getting? So isobaric heating work done can also be written as nRdt, and this is equals to A. This is given in the problem. The work done in the isobaric heating is nRdt, that is equals to A. So this is my equation number 1. Now I want to find expression for du. du is nothing but ncv dt. Now let us say this they call this equation as 2. If I divide these two equations, so that is this side nRdt divided by ncv dt. Now this side you have A and this side you have du. So if you divide those two equations, you will have A by du. I can write A by du. This is equals to dt goes and then goes to R by Cv. So you will have du is equals to from here ACV by R, and Cv is R by gamma minus 1, so A into R by gamma minus 1 into R. So R goes, so I will have du is equals to A by gamma minus 1. Are you getting? And the question asks what is the amount of heat that has been transferred. Now you apply the first law of thermodynamics and give me the answer. I think I will wait for 30 seconds because this is the easiest problem we are doing. So give me the answer for dq. I am waiting for some time. So I think all of you have get the answer. Now apply the first law of thermodynamics. dq is equals to du plus dw. du is A by gamma minus 1 and dw is A. So you will have A common, and you should do this into summation. You will have A into gamma by gamma minus 1. So this will be the amount of heat that is required in this process to perform a work done A. Capital A is the amount of work done that has been performed by the gas, and that's why it is positive in sign. We'll discuss the next problem. I think all of you have copied this one. Easy problem. So you see, in this process what we have learned, that is if you know work done dW, you can always calculate du, because we have a relationship between dW and du. This relationship will be related by ideal gas equation and the name of the process. So from ideal gas equation and name of the process, you eliminate some variable and you express work done in terms of dt, and then you divide these two equations, and see dt divided by work done as a function of dt, you will get du as a function of, so you see here, you will get du as a function of CVR and work done A. You can do the same kind of questioning in other process also. Only thing is you have to differentiate the given equation and you have to apply the name of the process, condition of the process. We'll discuss the next problem.